In this statistics section, we will be discussing statistical and critical thinking. This is pretty much just an overview of what statistics is, how it works. It's just about the process. And there's just kind of basically 3 stages where we prepare, we analyze, and we conclude. Pretty straightforward. So I'm not going to read the slides to you. I'm just going to kind of go through things, talk about them. And if you have any questions, feel free to email, leave comments, whatever it is you need to do. All right, here we go. So definitions, always very important when you're starting a course. Data. Data is just what we're collecting. Could be observations, measurements, responses from surveys. It could be just about anything. But it is whatever that we are collecting. Data is plural. Datum is singular. And I know that that's nitpicky, but it's really important that you know the correct singular and plural forms of this word. And then the definition of statistics, which is just the science of planning studies, experiments. We're going to obtain data from those studies or experiments. We're going to organize that data. We're going to summarize it. We're going to present it, analyze it, and then interpret what that data means and draw conclusions from it. So statistics is a multi-level thing. Everything that we use throughout the whole course will be used at the end. So by the time we get to the point where we are testing our hypotheses and this kind of thing, we will be pulling in all the information we've covered the entire course. So please make sure that you're just paying attention to that. You can't forget anything because everything is going to come back later on. Another important definition is population. And this is the complete collection of all of your measurements, of all the data that's being considered. So if I'm talking about a population, and I'm going to break it down by race, the population of the United States would be my population, every single person. Now, obviously, finding the race of every single person is very difficult. That's why we have census. Okay, that's why they only do a census once every 20 years, is because it is very difficult to get that information on every single person. Usually we use a sample, which is just a sub-collection. So rather than asking all 331 million people in America, we might just go out and collect data on, 1,000 people or 2,000 people, and just use that sub-collection, what we call a sample. All right, so just an example to kind of help you break these down. Okay, so if we had a survey of 410 human resource professionals, and 148 of them said that job candidates were disqualified because of information found on social media postings. Okay, who is the population in this scenario? Okay, the population would be every single human resource professional that exists. Now, obviously, we can't talk to all of them, which is why we only chose that survey of 410 of them, and that is your sample. Okay, so the sample is the 410 people that we took, that we surveyed. And then the last is, what's the objective of the survey? I honestly don't know what the objective of the survey was. It could be anything from, maybe they're just the companies are trying to look at, are they letting go, or are they letting go of too many candidates because of their social media posts? Maybe social media is something we shouldn't be looking at. Maybe we should. I don't know. So the objective of the survey might not be straightforward here. But whenever you're doing a survey, you should make sure that you know what your objective is before you get started. So very important that you know what that is. All right, so when you're doing a statistical study, there is a process. So step A is going to be, you're going to prepare. Obviously, you're going to have to make sure, what's your objective here? What are you trying to get to? Does your context is important? What does your data represent? What is the goal? Like, what are we trying to get at? The source of the data, make sure that your data is unbiased. Is it from a special interest group? That kind of thing. Anytime that you hear about surveys or polls, make sure that you're looking at, who was polled, who was surveyed, because there could be bias there, and we want to make sure that that doesn't happen. And then, what sampling method did you use? We're going to talk about sampling methods later on. Was the data collected in a way that's not biased? So we got to make sure that we take care. We have to think about every single little tiny thing when we do a study. Once we gather all that data, we're going to analyze it, and we're going to start by looking at graphs of the data. There's many types of graphs that we could look at. We're going to explore the data. Are there any data points that stuck out that were a little strange or a little odd or too high or too low? So we're going to look at that kind of thing. There are lots of different ways to summarize the data. So what's the best way for our data to do that? Um, how was the data distributed? How was it, if we look at it on a graph, is it all bunched up? Is it spread out? Are there data points that are missing? That could be a problem. And were there people who we tried to survey, but they refused to respond? That's another, thing that we might want to look at. And then we're going to do all different kinds of things with these statistical methods. A lot of time, technology will help you out. Pretty much everything that we're going to do, you can do on paper. There's very few things that actually require technology. I mean, obviously you can use it. We have it available, so you might as well. I know that you guys will be using StatCrunch, but you can use Excel. You can use, I mean, there's lots of different, and depending on where you go to work, there'll be different software packages that you can use. And then we're going to test our claims, like test our hypothesis, just like we would in a science class. We're going to test our hypothesis and see how it works out. And then step C, the last step, which is kind of the most important one, we have to make conclusions. Okay. Did our data show what we thought it was going to show? Did it not? Is it statistically significant? Oh, I have a typo on there. The results have statistical significance first, and then do they have practical significance? Because sometimes what seems important statistically isn't practical. So these are all things we have to think about. And I'll make sure I fix that typo on the slide. All right, so just to give you a taste of what you might see. Again, we're not going to get too deep, but I just want to give you. So here's some data that was collected in a forensics book. So all of the data that you're going to see is actually real data where I'm not making any of this stuff up. Talks about shoe print of a perpetrator of a burglary and then the height of the burglar. So context, what does this data represent? So this data is just shoe size and height of the burglar, period. And it turns out that they are all males, by the way, which is kind of important because males and females have different shoe size and different heights, so that's important for us to look at. The format is pretty straightforward, right? We just got a simple table, makes it really easy for us to look at the data. Context, what's the goal of this study? If I were to ponder, I would assume that we're going to try to be, if we can see the shoe print of the burglar, we can make an estimate of how tall he is. So that's what I'm looking at. That's the first thing that comes to my mind. The source of the data, is it a biased source? Is it a reliable source? This was actually taken from a textbook, so I would feel that it's probably not a biased source. Is it reliable? I mean, if you want to do some research on Brenda Roran and find out how reliable she is, you go right ahead. So I think this is a reliable source, and you'll find that a lot of people use the sources that we're all going to use are all very reliable sources in this class. So don't worry about that part. And sampling method, is it unbiased? Some people may say, oh, it is biased because it's just looking at males. Well, men are most likely to commit burglaries, so it makes sense that these would all be from men. So it's not biased. They just went to the crime scene. They took it. It's totally random. I don't know who committed the crime, but that's what I'm trying to figure out. So I would believe it was an unbiased because all of our individuals were random. We didn't pick them. They chose to do this crime. So looks like we're good to go. The procedures for collection, that's going to be based on your forensics, your CSI people, crime scene investigators. They have certain procedures they have to walk through, so I'm not too worried about those either. Voluntary responses. One thing that when you're taking a survey, you want to be careful that you're not using just voluntary responses. It's just people who want to participate. That can cause bias. So like if you're giving a survey about a certain topic, some people won't reply just because they don't want to deal with it. Some people will because they're very passionate about it. So you just have to be careful about that. You want to make sure you get lots of different types. Like if you send out a poll via the internet, like you just send out a spam email to a bunch of people, people will decide whether they're going to reply or not. Most people will just delete and throw it away. Mail-in polls, same thing. Excuse me. If it's junk mail, they're going to throw it away. Call-in polls on TV and radio, you have to be careful because there's only a certain population that listens to that certain radio show or that certain television show. And people who watch a certain show might have a certain, a certain bias. So you have to be careful about those kind of things with the voluntary responses. So just an example, ABC's TV show Nightline in the evenings asked viewers to call in and tell their opinion whether the United States should remove the UN from New York. 67% of the people who called in said that it should be. But then if we went and just did a random survey of 500 people, only 38% of that group wanted that. So that kind of shows you just how different the data can be from a voluntary response to a randomly selected response, which is why we really want to make sure that our surveys are always randomly done, because we want to get the best sampling of our population. When you're graphing these, if they're percentages, I think the easiest way to do it is just do a pie chart, 2 pie charts right next to each other. Will very quickly explain the difference between these 2 data sets. There are lots of different ways you could, but I think a pie chart would probably be the best. And you can explore that a little bit, maybe look at some other graphs and see what happens. But as far as our statistical methods here, there's really not much to go on because it's just a percentage. So, I mean, we really don't use a lot of algebra in statistics. Some basic solving equations and that kind of thing, but we really don't use a lot of math here. Right? So you're going to find that a lot of this is more thinking and not mathing. A lot of use of common sense, a lot of use of logic, but not a lot of algebra. And then our conclusions, that those could be just about anything. Statistically, is the difference significant? Well, yes, right? There's a big difference between 67% and 38%. So I have a little slide here. Let me show you the... So statistical significance is when we say that word, there's something very specific that we mean. We mean that the likelihood of the event, the likelihood of that event occurring by chance is 5% or less. So is there's a 5% or less chance that this happened, that just this one time we got a 67% and a 38%? Absolutely not. That there was a reason that happened. But like if you're looking at, so let me give you an example. So if you go to the hospital and ask them for a list of their last 100 births and just gender, like were they male or female babies that came in, and you had 98 girls out of 100, that is statistically significant. What is happening? That's very extreme, and that is not by chance. Something's going on. But if you only had 52 girls out of 100, well, that's pretty close to 50-50, so that wouldn't be significant. So there's some things that we, and we'll talk about specifically how we calculate this and how we work with it. There's practical significance as well. Is it possible that, especially like if we're talking about drug, like all these pharmaceutical companies that do studies, and okay, is it possible, because they always have a placebo, like there's someone who's taking a placebo and someone who's not. So practical significance, like, hey, maybe we found out that this new pill really works great and it's highly effective and it's fabulous. But what if we find out that it costs $4,000 per pill and you have to take a pill every day? Is that practical? No. So you have to look at both the statistical significance of your results and you have to look at the practical significance of your results. Are they practical, not just statistically significant? So like I said, there's just a lot of thinking that goes on. All right, so here's a good example of that practical versus statistical significance. Okay, so we did a weight loss program, 21 subjects were on the Atkins diet, and they lost an average of 2.1 kilograms, which is 4.6 pounds for us Americans who don't use the metric system, after 1 year. All right, are the results statistically significant? And this is where you have to kind of look at it from a health perspective. Is losing 5 pounds going to affect your weight, going to affect your overall health? And the answer is yes. Especially if you have something like diabetes, just losing 5 pounds can make a big difference. But if we look at it from the flip side of, okay, to lose 5 pounds in a year, is that practical? Like, what if it cost, Atkins program requires a very strict diet, which is more lean meats, a lot of fresh vegetables and produce and fruit. So is that going to be practical for you? Maybe you live in a situation where that's not practical for you to go to the store and get fresh produce every day and, fresh lean meats that are organic. And so Again, it might not be practical, this diet. Statistically, it is significant because every 5 pounds that you lose will help you reduce your risk of diabetes, heart disease, but it might not be practical. All right, so when you're analyzing your data, there's some things you need to look at that could be problems, and you will get more in depth in these as you start doing. This is just an introductory course, so we're not going to do anything too crazy in here. But there's going to be a lot of things that you want to look at. Like one of the things is misleading conclusions, and this is this is what the media is very, very guilty of. When you're making your conclusion based on your analysis, you got to make sure that your statements are very clear, and that when you try to make them more user-friendly, you don't change what you're saying. And the media does that a lot. When they try to make the language more user-friendly, they change what they're actually saying. So you got to be careful with that. Sample data reported instead of measured. Make sure that, like, if you're asking people how much they weigh, right? People are going to lie about their weight. They're going to lie about their age. So rather than asking people, hey, how old are you? Like say, hey, can I see your ID and just get the year of your birth? That's it. So those kind of things, right? What people will report is sometimes not true. So you have to make sure that you're measuring your data and you're collecting the data in a way that you know you're getting the correct data. Loaded questions. When you give a survey, you have to be careful about how you word your survey. And I don't know if anybody's had this before, if they've taken a survey where they feel like they're answering the same questions like 5 times in a survey. That's because they're trying to make sure they don't have loaded questions. They're asking you the same question and they're going to word it differently each time to see if you answer differently based on the wording of the question. So you got to make sure that even how you word your questions, because that can mislead people. The order of the questions. Sometimes just by putting the questions in a certain order, you may be leading people to answer a certain way. So you got to make sure you randomize them. You got to make sure that they're not in any specific order. So unless that is the purpose of your study and your survey. So you got, again, these are all things you have to think about. Non-responses. If people don't answer, is there a reason? So maybe you gave a survey where you had one question on the flip side of the paper and people just didn't know they were supposed to flip the paper over. So maybe there was a non-response because they didn't realize it was there. So maybe that was your fault. Maybe you should have, formatted your page a little bit more user-friendly so that people knew to, or put something at the bottom of the first page like, please flip over or something like that. But then there might just be a question like maybe it's a question that people are uncomfortable answering, so maybe you shouldn't have asked that question, or maybe you could have asked it a different way. So if people don't respond, it's important that you understand why they didn't. Low response rates. If you give out a survey and you get low response rates, the reliability of your data is lower, and that's not good. You really want to have good response. So you have to make sure, mostly just because if you have a small sample size, there's just a higher likelihood of there being bias. So you got to make sure that you get enough people. And that's usually what happens is people get a survey, they don't have enough data, they crunch the numbers, find out it's not giving them the results they want, they have to go back and collect more data. You need a lot of people. You need a lot of data. And then another thing is percentages might be misleading. So if I tell you, like if you hear and the news does this as well, 23% of Americans believe blah, blah, blah. And then you look at the fine print and there's a poll and it was only, they only polled 500 people and they didn't. Okay, so saying 23% of Americans believe blah based on 500 people might not be the best way to go about things. So be careful when you use percentages. You just want to make sure that you're not misleading anybody. So anyway, so that's just kind of a brief overview. Please come back for the next section where we'll start talking about the different types of data that we collect. See you then.